Good day, and welcome to today's webinar on the benefits of a standardized communications layer in industrial automation, brought to you by CFE Media and Technology and sponsored by Kepware. Today we'll be joined by Sam Elsner and Philip Bard, applications engineers at PTC, whose focus is on the Kepware line of integration solutions. I'm Kevin Parker, the senior contributing editor with CFE Media. With real-time access to accurate and reliable industrial data, companies can improve processes, drive productivity, and make better decisions. But data access is especially challenging in industrial environments, which often include disparate equipment, a range of enterprise business systems, multiple production lines, and remote geographic sites, not to mention evolving regulatory and site security requirements. This is where standardizing on a communications layer is key. By implementing standardized data flow through a centralized and secure architecture, companies can provide a single source of industrial data to all of their automation devices, machines, and software applications. Our speakers today don't believe there should be or could ever be a single communications standard for industrial automation, but they do believe there should be as few separate standards as possible. Their interests lie in having efficient, secure means for managing applications layers using different standards with diagnostics for testing and troubleshooting, and the means to observe interactions between data sources and control targets, and between control clients and data consumers. During the broadcast, our speakers will contrast the pros and cons of different communication protocols, explore key data communication challenges, examine features common to communication layers, and explicate how standardized connectivity provides the performance and flexibility needed to future-proof your data for tomorrow. To get the best results from the webcast platform, please make note of the following as you participate in today's event. If you are having technical problems with audio or the slide presentation, click on the question mark at the top right-hand corner of your screen to bring up a list of system checks to make. If you are experiencing issues with your slides or audio, please refresh your browser or click the Refresh Media button directly under the presenter's headshot. If you need a technician, type a message into the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Questions area. During the presentation, you can use the Ask a Question box on the left side of your screen to type questions for the live Q&A session at the end. You may ask questions at any time during the presentation. We'll get to as many as time allows. To download the presentation slides and certificate of completion, use the Event Resources box on the left-hand side of your screen. You can download the presentation and certificate of completion until the conclusion of the webcast. The link will break when the webcast signs off. This webcast is being recorded, including the Q&A session. We'll send you an email message within a week with a direct link to the webcast archive. Now we will hear from the sponsor of today's webcast, Kepware. At the conclusion of the video, you may experience a few seconds of silence to compensate for varied internet speeds. Please stay tuned after the video for today's presentation. Welcome back. I'm now happy to introduce today's presenters, Philip Bard and Sam Elsner. Philip Bard is a Senior Applications Engineer at PTC with a focus on Kepware industrial connectivity. He has previous work experience in manufacturing, academia, and the professional motorsports industries. Philip combines technical expertise developed over 14 years in information technology with an unbridled enthusiasm for engineering, so as to provide his customers with the answers and solutions they need. Sam Elsner manages PTC's Kepware Sales Applications Engineering team. Sam and his team support Kepware business development, the global partner network, and extensive global customer base. Sam has a unique combination of business and technical expertise developed over a decade of work in academia, with nonprofits, and in the private sector. His experience in systems integration for industrial automation and enterprise IT systems is especially useful for helping Kepware users make the most of their integrated data connectivity. Sam, the floor is yours.
Thank you very much, Kevin. And thanks everybody for joining today's webinar. It's a wonderful pleasure to be able to speak with you today. So we're going to cover a few different things, all as it relates to communications layers within enterprise industrial environments. So we've carved out the themes of this webinar into 4 or 5 different areas. So we'll talk about the security benefit, the deployment benefit, the performance benefit, and the management benefit when significant time investments taken place into creating a plan around a communications layer. And then before that, though, we'll introduce you to the Kepware business and give you a little sense of what we're going to be talking about in detail today. So with that, I'll move forward in the presentation. I want to talk just a little bit about Kepware. I think maybe a lot of folks on the phone have already been familiar with us. If you're not, let me just say a few words. Kepware, as a private company, established ourselves in '95. We are located in Portland, Maine, so the original Portland for all the folks on the West Coast. That's a joke there. Anyway, we've been in business for, as the slide implies, almost 30 years developing communications products only. We're focused on industrial connectivity. We've been doing that for, say, the past 20, 30 years. We've got an extensive partner network all over the world, and we've got customers in almost every continent on Earth today. We've won numerous accolades and awards for our connectivity products, and in 2016, we had the happy fortune of joining PTC. So we're now, we were acquired by PTC in 2016. And we bring to them a huge number of connectivity tools for establishing data flow and controls within industrial environments. And we also bring a number of, a huge amount of human capital to the PTC organization, specifically around industrial connectivity. So that is a little bit about us. Moving on into the presentation today. So before we get into the weeds about communications layers, I wanted just to talk about briefly what are we talking about and why? So what do we mean by communications layer anyway? So on the left side of the screen, you can see one potential topology design, right? And on the right side of the screen, this is a graphic produced by Kepware's marketing team to talk about how a communications layer might be present in between certain, what we would term ISA 95 network segments. So I wanted to call out the diagram on the right because that's a pretty abstract diagram. Essentially what this is leading you to is some unification of communications between level 1 and level 0 and level 2, 3, and 4, and maybe even the cloud. So, protocol conversions may be in one corner of the network, but really this is an abstract idea, this whole communications layer, and this can map over to systems between, say, or data exchange between L2, L3, L4, and the cloud. And so the diagram on the left describes what one topology might look like, right? So topologies for this communications layer concept are going to be different. There isn't one holy grail. In this case, in this topology, instead of a single application sitting in the middle of everything, conducting translations into some standard protocol, what I mean by communications layer is a small translation application embedded, let's say, within each business system or each operations system, or maybe even within the cloud or even the operations assets, where the conversion into that local or that communications layer protocol, maybe more highly abstracted protocol occurs right on the device or system itself. Right, and so in this case, the topology is going to look quite a bit different than if you design something like this, where the diagram on the right is sort of an implication of this centralized, redundant, kind of communications layer that's creating this layer for you. But again, the layer topology, it's not the idea of a communications layer is not fixed on one type of topology. It's really more abstract. It's more about a decision to build a set of communications tools and continue using those tools or those protocol standards as the environment matures, so that integrations are streamlined and data flow can occur across disparate parts of the organization. So again, in the second design topology, we've got centralized communications layers where there's a centralized application that's handling, say, conversion between, the protocol and message data streams that need to be fed to each type of system, whether it's operations, business, or the operational assets, or even the cloud. Juxtaposed with the first architecture, which is really that translation's happening more locally, and applications are, in a sense, just communicating between themselves, albeit with the help of a local translation tool. So I'm going to turn the floor over to my partner here, Philip Bard, just for a sec. Philip's going to jump in and talk a little bit more about not design topologies, but about protocol standards in general, just to set the theme for today's discussion.
Thank you, Sam. All right, thank you, Sam. Take a moment here, let you digest the comic here, or Randall Munroe. He writes the XKCD comic strip online. It's tailored towards a nerdier, techier audience. I'm guessing those overlap with this audience here. But often people go, their CIOs, their CEOs go to these big tech conferences. They see all of this whiz-bang stuff with AR and analytics, and they come back to the people who are going to be implementing the solution, and they say, hey, get this into my systems. And the people on the ground who are responsible for getting all this data, they say to themselves, well, we have, 25-year-old Modbus equipment, or we have some old Emerson equipment. Like, it's not built for the stuff you saw in 2019.
Right. And so I think it's fair to say it's not that you're not necessarily going to be able to hook up that old Emerson RTU directly to Microsoft's Azure's IoT Hub.
Correct. So how do you get there? Ideally, we would have one protocol that spoke to everything, but that's kind of how standards proliferate. People say, hey, why doesn't this cover everything? And they make a new standard, and often, it's an improvement on an old standard, but then you have all that existing equipment in the field that is still using the old standard. And so, it's not feasible economically or even just in your production to go and tear everything out just for communication standards. So what we talk about when we talk about standardizing is getting to as few as possible as quick as you can, as close to that edge, as close to production as you can. An analogy I'll use here is this is actually just a few blocks away from us here in Portland, Maine. It's an intermodal station. And what it is a rail yard comes in and trucks come in and put everything onto a boat to go across the ocean. So, getting everything from disparate sources into one central pipe that is easier to manage, has economies of scale, and is built for a specific purpose. Like in this case, it's built across the ocean. I've seen enough episodes of Top Gear where they try to get cars to go across the ocean, but it's just this is built for it. And so you have rules within each of these transports that you can standardize on and then simplify on.
Yep. Thank you, Philip. And so there are certain, benefits to creating the sort of standardized communications topology. There are security benefits, deployment benefits, performance benefits, and management benefits. Before I jump into those, I just want to go back to one analogy or one example of what we're talking about here. So see on top there about how standards proliferate, right? There's AC chargers as an example, or there's character encodings, ASCII and others, and Unicode and all that. And then there's instant messaging. The design topology instant messaging, it's interesting. There's a definite parallel to the prevalence of instant messaging types and the prevalence of industrial communications protocols. So just like human beings need to talk back and forth, and sometimes they use different applications, well, machines are doing the same thing, and they use different, Ethernet or serial languages to do that. Imagine if the company wanted to record everything that was happening on any instant message platform, but allow a user to use their instant messaging tool of choice. So imagine a centralized deployment like this that is almost like a unified messaging server that can serve information to Skype, it can serve information to Link, it could serve information to, AOL Instant Messenger perhaps, or, Google Chat. Any of those standards could potentially be supported by this unified messaging layer, and then it has the benefit of allowing you a single focal point to record and then manage all of the interactions around the instant messaging tools. So in this case, this parallel of instant messaging, we might be able to create a communications layer by creating a unified server that supports all these different chat clients, but gives us a single pane of glass to manage and store the chats that are happening, within my company, within my organization. So anyway,
Sam, this is Kevin. If I haven't interrupted you, if you have more to say, but I do want to take a moment to encourage our listeners to send us their questions and perhaps ask a question of my own. If people think about Kepware historically, they think of them as having device driver libraries where one input was translated into another output. Is it fair to say that this is moving well beyond that kind of device driver strategy to more of a bus strategy where you have any variety of things that may come in as input and then are changed to an output as required? Is that fair, or have I got it wrong?
No, I think that's entirely fair. Yeah, and it's more than that too, though. We're not necessarily trying to, there's a goal of reducing the number of messaging protocols, especially as you move up to different layers within the organization, right? So if I move from L1 all the way to L4, I don't want to be using an abstractless, like a very context-poor messaging protocol to move up to L4. But it's not only that desire to translate something into, a standard, single protocol for use throughout the organization. It's also a recognition that protocols have their purposes. And you may not be able to isolate all of the kind of messaging you need to a single enterprise bus. And then at that point, your topology might look more like something like this, where the enterprise bus is really provided by an application, maybe like Kepware, that sits in the middle that can translate with a set of drivers or southbound and a set of server interfaces or publish interfaces in northbound, where we're serving data into business systems and operation systems in this particular native protocols that those applications like best. So it's really twofold, the themes in this presentation here. There is certainly a goal, as there should be, to reduce the number of protocols used in the organization, but we shouldn't just blindly have a goal of reducing it down to one, necessarily. We may want to or need to acknowledge that there are useful aspects of certain protocol standards that, layer 4 that need to be maintained, and so our goal is to translate something on layer 1 to something to layer 4. Both topologies or both themes would be, in my mind, a communications layer, as exemplified by perhaps, these two different kinds of topologies here.
Great,
thank
you.
Thank you. All right, so into the different reasons why someone might want to standardize on a particular communications layer. So the first reason would be security, which is a huge discussion today, of course, with all of the abundance of Ethernet or Internet protocol accessible endpoints popping up within the network or within a plant, but outside of our network. I mean, it's a really important topic of discussion. So if we're able to, move the data to a standard messaging layer, or at least to move the data to an application that can convert data into another kind of messaging that's more appropriate for different parts of the organization, what we get the opportunity to do is have a fixed set of let's say, data payloads, at least that we can view, whether it's within the application that's conducting the translation or just listening on the enterprise message bus anyway. So on the left, you could see a screenshot of an Ethernet dissector called Wireshark. It reads network packet capture packet capture files. So if you look at what is happening in green, it would be wonderful if everything was plain text and human readable to me, and I could use a network dissector just to open it up and take a look at it. I would be able to potentially allow, IT admins or others, or with certain dissection tools, I can use encryption and still be able to parse and dissect packets. They would be able to have a standard set of tools that they could use to quickly and easily look into the messaging layer for troubleshooting and different kinds of either network infiltrations or deep packet inspection that could be occurring automatically by algorithms run against data on the enterprise bus or data coming out of the communications tool. So, normalized data payloads out of the communications layer, they offer, consistent message types for inspection and routing algorithms. So it pairs up really nicely with IT. So if you said, well, okay, all this layer 0 and layer 1 stuff, I'm going to make a standard effort to turn it into JSON structures inside of HTTPS. That way, I can leverage port 443, which my IT team is constantly running deep packet inspection algorithms on 443 because it has, public and private certs necessary to do so securely. So you can have a much better time integrating your, say, IoT data needs or your traditional industrial data needs with the rigorous security paradigm set forth by enterprise IT if we're able to leverage standard messaging transports like HTTPS that have a huge foothold in enterprise IT or in business systems or in Ethernet networking in general. And have a number of security products available on the market that tie into them natively and can help protect the network. The other thing that, can benefit from standard messaging layers is, standardized access. It reduces the number of open ports, and it may eliminate the need for inbound ports. So, firewall considerations and routers. If you're working to get things more consistent to a single or at least a few different messaging protocols on layer 3 and layer 4, out of layers 1 and 0, you may be able to move that data more securely out of the network if you turn it into, for another example, an OPC UA packet that is secured using SSL, even before it leaves layer 1. Right. So there's certainly security benefits to focusing on creating a communications layer that's standardized, both in the type of application that's used to produce it and also the messaging layers or messaging streams that come from it. So again, just to reinforce this idea, we can oftentimes take a layer 0 or layer 1 protocol and convert it into something more secure for transmission throughout the rest of the network. And in this case, let's say it's payload encryption and unambiguous identification through certificates. That's something that OPC UA offers. So instead of passing Modbus, which, believe it or not, 20 years ago, Modbus was a fine tunneling protocol and security was an afterthought. At this point in time, it would be crazy to pass pure Modbus across the internet. Anybody could look into that packet. So you need to encrypt it before it leaves your network, or maybe even before it leaves layer 1 or layer 0. And the only way to do that, because Modbus doesn't offer at the application layer or even transport layer any recognition of security or encryption, we'll do a complete protocol conversion into something else. And in this diagram assumes it's OPC UA, but by the time it gets to the NPC, we might have converted that back to maybe a business layer protocol like HTTPS.
Well, one more thing, Sam. Standardizing on a port also simplifies things for you because, Modbus is generally port 502. I'm trying to think through some others. Omron is 9600. Instead of opening a bunch of ports in your firewall to pass this traffic, if you're passing it all through, say, like this OPC UA tunnel, it's, port 49320? Mm-hmm. And so you have all these different devices using different ports and different protocols that are not ready for the cloud. You're putting it into something that's ready for the cloud, and then for configuration when you're working with IT, because there is that convergence here. I know a lot of folks here are not IT, they are in the operations technology. you're just going to your IT folks and saying, I need this one port open. Just monitor this one port.
Thanks, Philip. Great. With a standardized messaging or a few different standardized messaging protocols selected, or with an application that can serve, various messaging types that application could function as the comms layer, you get rules-based data access and rules-based configuration access as well. So really focusing people in on who should have access to this data and, for how long, who should not have access to the data, or beyond just access to the data, can they read it? Can they write it? Can they create new elements that allow us to attach to new kinds of data streams? There's all these, once you're working with a common set of tools or a common protocol, there are features that you're able to take advantage that offer you benefits like controlling the type of access to all this different data. And of course, different messaging algorithms use different authentication mechanisms. Some applications, from a data conversion or data gateway standpoint, tie into LDAP or Active Directory. So some of this can happen automatically. And that's the theme here. It's that, if you, again, try to reduce the number of protocols used in the environment, if, you're moving the data out to a higher level network layer, or even within network layers, try to use a highly abstracted feature-rich standard that provides lots of metadata and potentially security benefits like access control. That would be important to include in the decision about, A, what type of application to employ for, conversion-based communications layer stuff, and then what kind of enterprise bus protocol to select, because you want it to have, rules-based data access. And then finally, as I mentioned previously, some of these either messaging layers themselves or applications that conduct translation, they might tie directly into LDAP or Active Directory. But at least it's, central or at least identical management points for different systems integration. So you're not having to learn, 5 or 6 different user managers and authentication mechanisms just to support the kind of data flow that the company needs throughout the organization. So next up, we'll discuss deployment.
All right. Thank you, Sam. Looking at deployment here, this slide just illustrates complexity if you're making one-to-one connections to all these different things. So, you have your PLC, your device layer, and you say, well, I want to connect it to HMI. And so you connect it to HMI. And if with no layer in between, you're making these one-to-one connections. So there is that bottleneck of you have to get that all set up. There's also another where, maybe the device can only handle one connection at a time. So you create this queuing problem. And then every time you add a new feature, let's say you're using an HMI, but then you go to a historian, or let's say you start building something in Azure. You want to start using MQTT. I saw one question asking if we are talking about MQTT, and that is one of the protocols we are talking about and capable of publishing with. You get this mix mash. Every time anyone sees anything they want to add to it, you have to make these one-to-one connections. So, going back to that intermodal station example, you have all these single transports of a truck taking to the intermodal station, and then you've got these shipping lanes you can send things out in. So as you add new capabilities to your business systems, let's say you start with an HMI, but then you start getting into you want analytics. You don't have to redo all the connections you've made to your industrial devices. Those have all been established when you set up your communications layer, in this case connecting to KEP Server EX. I did see someone asking, isn't the Kepware Protocol Translation Server basically a network gateway? They've been around for decades. What's unique in your approach? And the analogy I usually use is, you think of a translation, you might have an English to Spanish dictionary or something like that, but then you have C3PO in Jabba the Hutt's palace, where we speak 150 protocols, so we can take on all these devices, and we're adding new protocols every quarter. So, you might be doing something as standard as a Siemens device or an Allen Bradley device, but then someone's going to bring a scale to you in one of your facilities and say, well, I have this and it runs on SAT-bus or something crazy like that. You don't have to spend a bunch of time learning a new language or putting in yet another gateway, because most gateways I've seen for industrial protocols are one-to-one, like it's a Danfoss to Modbus type thing, XML to Modbus, or a field bus to Modbus. You can handle multiple in one central location.
Yeah, just to add to that, I think we might mention this a little bit later in the presentation, but there is a request for a real-world example of some of these topologies, and here's one, right? Philip, I'm going to talk about the Faurecia case study. The Faurecia group out of Brazil, they were interested in integrating a series of Siemens PLCs into their manufacturing execution system, their MES. Their MES was entirely homegrown. It integrates to, it's really comprised of a bunch of different services that work together. It integrates to a bunch of different IT systems. And guess what the enterprise bus of choice is? Well, it's HTTP and JSON structures, right? So everything in the organization is really run by this MES, at least from the standpoint of process-oriented manufacturing. And so that was sort of the pinnacle, the heart of their whole organization was this MES that standardized on the use of HTTP. And so the poor folks, 15 years ago, they wrote a little translation application to take data from an OPC server that was connected to Siemens devices. And they wrote it in an OPC DA client environment. And it was really hard. They didn't have a ton of background in OPC, Microsoft Component Object Model programming. OPC DA has, it's certainly showing its age in modern development environments. They really struggled with it. So they came to us and said, look, we're interested in enhancing this interface. What would be great is if we could get you to speak the language of our entire organization, which is HTTP and JSON. And luckily, they had chosen Kepware for their communications layer application to conduct either gateway protocol conversions or driver-based, protocol conversion, that kind of thing. And so we were able to convert the Siemens PLC data directly into HTTP and JSON with the type of structure that they can easily parse and use within their MES. So that's also what I might mean about normalized data payloads. The company decides what is normal, whether it's an XML structure, a JSON structure, whether it's even human readable. Maybe it's a binary structure. But it's normal because everybody uses it. And then it's the data payload would be that normal structure that anybody peering in could immediately understand and take a look at. So this worked really well for Faurecia. We converted everything into HTTP and JSON structures, and they were off and running and developing right away. Other companies, they might acknowledge that, they have HTTP requirements with JSON, but they also have MQTT clients that need that, and they have traditional SCADA. So their enterprise bus is, unfortunately, they have to have at least 3 different protocol standards employed. So this concept of the communications layer might change from one of let's use a normalized data payload for everything like an enterprise bus to one of let's select an application that can convert any data stream we need into any other data stream that we need so that we can plug everything in together and exchange data as if things were on a normalized payload, that an enterprise bus is delivering. So anyway, I wanted to jump in. I thought that Philip did a really good job there. I just wanted to piggyback on that for a second and pass that right back to Philip.
All right, thank you, Sam. So along those lines, you see on this bottom layer, we see the vendor protocol A, vendor protocol B, vendor protocol C, all these different protocols, whether it's the, speaking to Allen Bradley, Siemens, Omron, Modbus devices, every time you add a new shipping lane, to use that analogy again. In this case, we're showing OPC DA or UA up to a server or REST MQTT up to a cloud. So every time you add a new business system, you're not relearning the communication layer of the devices. You already have that in a format that you can change or add to. So you could go from OPC UA, and then someone says, well, I'd actually like it in SQL. I'd like to send this to my SQL server. No problem. We'll just add another stream here and send it out as an insert into a SQL database. So at a higher level here, let's see. I saw some people mention that they had more of a mechanical background. That is my background as well. I was in mechanical engineering. I often say that I'm an animal they shaved and put in front of a crowd. So I try to dumb things down a little bit here. So in this, I have just some very simple pictures. We have on the left, we have our factory. And if you look on the controller, there's an address range of K001 to 0009. That makes no sense, right? If you send that to the business system all the way up to the top, it doesn't make any sense to anybody. So, you know, we put it in this communication layer, and we can name these things: current, good quantity, temperature control, how many machines are online, if it's running, what the temperature is. And so this is in the KEP server layer, we see the address, the actual K0001, and the data type, and then we can name the tag and give it some context. You take it from there, and then you abstract it and you convert it to whatever that standard you're on. So in this case, now we see it in OPC. So this is OPC DA here. We see the names in an OPC address. We see the data type. We see the value, timestamp, and quality. And we see how many updates we get. So, you know, sending to an HMI, sending to a historian, this is how it would look to them. This is what they want to see. They don't want to see K0001. Further up the line, this is ThingWorks. So this is another PTC product called ThingWorks, and it just sees the names of the values. If they go look at those values, they'd see what they are, but they don't. It strips away all of that stuff that wouldn't make any sense, or they don't even need to know. They don't need to know the actual address on an Allen Bradley controller or Modbus. They don't need to know. They just want that raw value. So when we start talking about scaling, you're building out your solution. And what we often see are people do like a proof of concept. They say, well, I have 13 facilities, but let's try this on one line first. So they build out their solution, their application online, you know, in the cloud, wherever, in the central hub, and they build it out and they say, let's connect to our first site. So they go to the first site, they go to this factory, and it speaks, we're getting really generic here, Protocol A and Protocol B. They put a local translator here, in this case Kepware, on site, and then it translates that to whatever they standardize. So we say Protocol Z here. What we normally see happens when these things get going and they're successful, they do it at plant A on a line, and then someone else says, hey, I'd like that too. But maybe this plant was built 10 years later. Maybe it was acquired through two companies combining. And so they don't have Protocol A and Protocol B on the floor. They have Protocol C and Protocol D. You put in your local gateway here, is your KEP server, and then you standardize on that same protocol. So everything you've built in your HMI or your analytics or whatever you're showing here, your business systems, stays the same. When you add a new site online, and we'll do this again, maybe it's a mix of what you've had before. Everything new coming to the business system looks the same. Do one more time, Protocol X and Y, and then we're all standard on that. Or, you know, maybe you needed Protocol Q here. You could add, but you don't have to do a lot of the work again. You don't have to repeat yourself when you build your infrastructure, when you build your structures for what you're going to be applying this data to. It allows you to deploy quickly because everything's in place. You're just changing the adapter, essentially. And so Sam already spoke about the Faurecia example here, but the idea was we were able to get the data from their controllers and then put it into a standard they already understood. They didn't have to relearn OPC UA or OPC DA. So looking at what you have on hand already, you know, work to those strengths. If you have developers who are already great using tools that use OPC UA, fantastic. Maybe you have some developers who just want everything into a SQL database. We can send it there too. But we get it from that industrial language, very esoteric, into something that your developers or your team can work with. So once you're deployed, now we look at how having a central location can help performance. So the configuration becomes very simplified here because you're only learning tools at each layer. Like at the factory layer, you learn, in this case, KEP server. You learn KEP server, you learn how to apply it to all your devices and get everything into one protocol. At the bottom here, I have an IoT Edge application. So from KEP server, I'm using MQTT to send up to the IoT Edge. I only need to know how to develop on the IoT Edge line or side. So I only have to see, you know, if I'm in charge of that, I don't have to know how to get an array out of an Allen Bradley controller. I just see that array presented to me in IoT Edge. I don't have to worry about any of the layers before it. I see it abstracted in something I understand, whether that's, you know, a set point, an on-off, a temperature, a voltage, a sine wave. These are all things that get abstracted, and I don't have to learn every time they say, cool, now do that on our press, do that on our CNC machine, now do that on our wind turbine. These all look the same at that top layer. The diagnostics become simplified as well because you have this central hub everything's going through. Sam had the Wireshark example earlier. We have some built-in with some errors that show, you know, based on what we're seeing from the controller itself, or we can even look at the transmission coming across the line and just see into what's coming across and make sure it matches what we expect.
Right, and if you were using an enterprise service bus, you know, instead of, say, focusing on an application to conduct all the translation for you into some proprietary format, it would be expected that the enterprise service bus that you would choose has, you would have tools to quickly and easily look into those normalized data packets and see if there are errors or see if there are, issues going on the network, because the packets themselves might be self-describing. You might have chosen part of that JSON structure might have a few elements to talk about, success or failure in acquiring the data from the target system and other metadata about maybe errors that have occurred during that. So the idea would be that, whether you used an application or series of applications as a layer to conduct conversions for you, or if you went to the enterprise bus route, in either case, you would get the advantage of simplified diagnostics for different reasons in each example, but still the same thing would be there, the simple, easy way of looking in and understanding what's happening in the network, and thus the end devices.
Yeah, and I see a performance-related question here asking if that creates a network bottleneck at all. And that's a really good question. So, you're going to connect to all your devices on the floor, and some PLCs you connect to might have 90,000 tags in them. But you're not going to be most likely asking for 90,000 tags every second. So, there's going to be some key performance indicators you're looking for. Maybe it's 50 to 100 to 200 that you're pulling in, and we'll be reaching down to those devices, but we're only going to send up to HMI, to the HMI, client, Azure, whatever you're sending to on change. So it's not a bunch of chatter across the line. And actually, let's look a little further here on the next slide, because we're going to talk about, two of the main ones we talk about. And one of the performance things you can look at is you can tailor to your environment. So, if you're in a high-speed network on a factory floor and it's very controlled, you could look at that traditional OT network with OPC UA because you have high throughput. You can get a bunch of tags at once. But, often in things like oil and gas or water treatment, you have a bunch of equipment that's out in the field. And it's far-flung. It's using cell towers to get data. So, you don't have the luxury of that high throughput. So maybe you use something like MQTT, where it's a publish-subscribe methodology instead of a client-server. With a client-server, it's saying the client is saying, hey, give me this data at this scan rate, and we say okay, and we go down to the device and grab it. PubSub is going to just send out changes whenever they're there, and then what would traditionally be the client or the endpoint is just listening. It's subscribing to that, so it's not reaching out across the wire every second saying, give me this data. It is just saying, hey, I'd like to know when this changes, and then the MQTT device says, great, I'll send it to you when I have a change. So, for performance, you can tailor to your environment. And we very much encourage benchmarking. Anytime you're building in the solution, you want to make sure that you can handle the throughput you're looking for, and look at the scan rates you want. Sometimes people will ask us for performance, and it turns out they didn't need that level of performance. Maybe they're, they start saying, well, we want something every 25 milliseconds, but changes only happen every minute on this device. So you build out your benchmarking, and it's something we encourage to test and make sure that you are, getting the performance you want around the environment, what's feasible in your environment.
Yep. And as for the specific question around the Kepware product, if it were being used as the heterogeneous communications bus, I liked that phrase. As the application to provide that communications layer, we developed the application to run in parallel on a number of different data streams and a number of different protocol drivers or translators. So as load increases, we scale that out through allocating additional process threads within KEPServer, meaning we'll scale when needed and we'll contract when needed to still support, quote unquote, real-time operations to the tune of, say, 50 to 100 millisecond cycle times.
All right, Sam, next is you.
Okay. All right. So lastly, I wanted to talk about the management benefits. So these are probably pretty obvious by now. If you're able to standardize on a single enterprise bus or a single, protocol or a communications layer application that provides, heterogeneous protocols for, different corners of the company, then, you get certain benefits in day-to-day management of those technologies. So, first off, you don't have to learn all of these different tools just to do your job. You end up needing Wireshark for the enterprise bus and, Postman to inject, HTTP and JSON packets into the enterprise bus to see how things work, right? So you build expertise in packet dissection and in an HTTP client, and then you can do your daily work because you're not having to, learn every single individual protocol that is, being used by these disparate systems. If you do end up going with, an application for a communications layer, then at least you have the focal point of the diagnostics and troubleshooting being that application where we have tools to show you what's happening within all these different proprietary languages that you might not otherwise have access to. So really about a single consistent set of tools for, a variety of communication tasks. And, it's better, the ideal is not to run multiple types of applications that deal with the same work, for a different data stream and with a different workflow, with different licensing mechanisms and troubleshooting techniques. I mean, in our operations tech world, I think, hey, a lot of our customers run, vendor-provided OPC servers and, say, Matricon OPC servers and Kepware OPC servers and maybe Softing OPC servers and others. If there is support for all the different kinds of protocols you need and features you want, then it's best to consolidate those down to the fewest different types of applications as you can, because obviously that's going to chew up less of your own cycles in learning them and maintaining them. Secondly, IT-driven tasks or OT-driven tasks around system reliability, they're easier if things are standardized, either on a single set of applications to perform translation or maybe even on an enterprise bus. So, tracking of those messages on the enterprise service bus, they could all be, kept in a transaction log and stored. Or if it's an application that's providing you translation, well, maybe a backup software. If it's the same application, it's easier to configure backup software to go out across the network and grab, important files from the same locations on all these different PCs because the same application was installed and configured in the same way to create that single uniform communications layer. So, and again, of course, then we get other benefits like being able to manage the deployment of security updates to those translation applications. You can, potentially centrally manage version control of those applications as well. It's really about reducing the different number of applications you need to learn to support your enterprise bus. And reducing the day-to-day drain on your own time by having to support so many disparate either, Ethernet or serial protocols or applications to support that enterprise bus. So I wanted to move into a topology example using KEPServer, and then we'll jump right into questions. So the topology example using KEPServer, it's in this scenario, it's not building a single enterprise bus. It itself is functioning as that heterogeneous communications layer or the enterprise bus where the only movement of data in the same form is within Kepware, and everything outside of Kepware is one protocol translated to another. So this is a bit of a sales pitch. I just, want to give you guys a heads up. But this is a really interesting way to show how many different kinds of translations Kepware can conduct, where Kepware becomes that single communications layer or a communications layer application dealing with a variety of different protocols for different purposes. So first off, we might have PLCs, connected with drivers, robots and motors and all that kinds of stuff, or sensors directly connected. We'll connect those up with Kepware drivers, and then maybe we're supporting local HMI. Right, maybe there's a bunch of OPC DA-based, FactoryTalk HMI panels that are pulling data remotely from, the instance of Kepware that's connected to all these PLCs. Then maybe at the same time, we've got a new set of OPC UA-based applications that also need data, whether it's SCADA or whether it's, HMI. And then from there, maybe we have DCS and RTU systems to connect to. So big equipment, things with PLCs already included, and just not general purpose, custom automation lines. Maybe we're talking CNCs and pump systems and, surface mount technology, all kinds of stuff. And so we're able to use PLC drivers and RTU and DCS drivers to speak with them at the same time that we're doing the other PLC work with robots and sensors and direct PLCs. Then, maybe at the same time, the company has a series of Wonderware, HMI panels that just can't go away, or maybe their SCADA is based around Wonderware, and there's such a substantial investment that maybe they're not willing to rip that out and replace it, and maybe it makes no business sense to do so. Well, why don't we use the communications layer to convert the information into the native format for that Wonderware panel? So we support SweetLink natively and other kinds of proprietary interfaces for different SCADAs. And then at the same time, hey, why don't we just go ahead and push data into a historian or a database, and maybe we do that directly interacting with the database ourselves, or maybe, they're using SAP or OSI Pi or FactoryTalk Historian or Wonderware Historian, and they're using some kind of OPC or DDE-based standard to get information out of Kepware. And then at the same time, we have a new Wayscale or a barcode or RFID reader that comes online that has a really simple, say, ASCII-based protocol. Well, we can develop a simple profile, as we call it, in the user configurable driver, and then we end up integrating the Wayscale natively into Kepware, and then we make the data available in whatever format is needed. So we could log it to a database using ODBC, or we could serve it over OPC UA. Maybe we're using, building automation standards as well. Maybe there's an effort to, have some environmental monitoring occurring, and the HVAC system has a protocol that we support. Maybe it's BACnet. And then maybe we have specialty drivers for different kinds of custom equipment that have occasionally happened over the years. So all of this, and also we might be monitoring IT systems like Cisco switches over SNMP, for example. And then maybe we're using third-party OPC servers as well, connecting to them over OPC DA. And then maybe you have a secondary instance of Kepware. We can get into redundancy at some point, probably going to be outside of the scope of today's discussion, but we can talk about that, certainly follow-ups. And then maybe there's a custom OPC client being developed. And then that is just what happened in operations technology. Right? What about all of the other areas of the business? What about, what about the efforts of creating hybrid applications between, cloud and on-prem? What about, business reporting systems like JD Edwards? Or what about, different kinds of inventory management systems that might be under the purview of IT instead of the operations and controls engineering teams? Well, we can't force an MES to support, say, BACnet if the vendor isn't willing to do it, but the market has shown developers that OPC and HTTP and others are great standards to support. So let's just convert, various levels of low-level protocols into something more appropriate for that MES or ERP system. Let's move it to enterprise databases. So outside of just a plant database, maybe we move that up to a big Oracle system that's running the entire company. And then maybe we, communicate up to corporate HQ with a very small visualization of what's happening at each plant. Maybe it's web-based. We could support OPC UA or HTTP or MQTT. And then maybe that you have remote sites that also need access to information that's happening within this one plant. So we can support that in a language, in a protocol that makes the most sense for remote sites. And then maybe we get into the world of big data and big-time analytics and cloud. Then, there's a whole different series of standards that a lot of folks don't have any interest in employing in operations tech or any ability to yet, but are a prerequisite for doing anything within, say, cloud platforms or big data analytics. So, on the one hand, there's certainly an effort to consolidate the number of protocols that you're using within the operations tech networks and environments, and it would be wonderful if it was a common protocol that could be used on the low-level controls network and on the higher-level business networks, and maybe even all the way to the cloud. And that was possible for ASIA, for example, but it may not be possible for your environment, in which case you could focus on an application like Kepware. We're not the only game in town, but you could focus on an application like Kepware conducting specific protocol conversions for you, and that application effectively becomes your communications layer and your standard way of moving data around your organization. So with that, that is the last piece. And I wanted to open it up to discussion and questions with the time that we have remaining.
Well, thanks, Sam. I'd like to say you guys really know your briefs, and thanks for that detailed presentation. We don't have much time left, and as someone said, this was a webinar that was going to get a lot of questions, and it certainly has. I'm going to ask one general question. You guys did a great job of answering questions even in real time as you gave your presentation. I'm going to ask a general question. If there's a detailed question that you want to answer after that, just let me know. My question is, one of our readers has asked, isn't this adding more IT into the operations technology space when what we need is operations technology? My understanding is that the long-term trend is, in fact, that IT standards are being introduced into what were proprietary OT spaces. How do you see that line, IT-OT line shifting, and what's the overall story or narrative from your point of view?
That's a really good question, Kevin. And thanks for the person who asked it in the question and answer pane. I think I'm not ready to hang my hat on one or the other. But I do have some specific examples that could push us in one direction or another. There's certainly learning, and what we've found is there's so many analogies here. As Kepware has become part of this bigger organization focused more around IT, we've done a lot of learning ourselves, but we've also taught our parent company a lot about operations technology in terms of both business detail, but a ton of technical detail as well. So there's learnings really happening on both sides. On the IT going into OT, what is really happening is the OPC UA or OPC Foundation has created a unified architecture, which is an incredibly flexible and still being developed protocol standard that meets the requirements of both IT and OT. So we're seeing a lot of IT folks and maybe vendors who are more traditionally IT focused, like Microsoft or Amazon. They're adopting, let's say, I don't want to speak for Amazon, but let's say Microsoft, they're adopting OPC UA directly within the Azure platform. Right, so that's, say, on the one hand, that's IT adopting OT tech, like an OPC standard is being promoted for use of Microsoft developers, which really is a rarity. That didn't happen as much with OPC DA. But, now it's front and center, and the way of, Azure is communicating to the industrial edge. They're using proper nouns like industry along with OPC UA, right? So, but the OPC UA spec was greatly influenced by what's been happening in enterprise IT, specifically around moving data over internet protocols. So, over TCP/IP. Right? There's lots of different methods of moving data over transports, over IP, but there's been essentially consolidations around certain decisions with regard to messaging security and authentication that the OPC Foundation has adopted. So the learning is really going both ways. To the standpoint where, we need more OT and IT, I'd agree with that. And then I'd also agree we need more IT and OT because both have value. Where OT, I think, brings the most to IT is in an explanation about how the data is produced and what it means and its context. And then with IT, it's about, okay, they're responsible for moving the data around and out of the organization. We need to make sure that whatever's being produced in OT matches the requirements, and at least in terms of security as it relates to IT. So really both ways. And I know that's a kind of a diplomatic answer, but it's the true answer that I have. I see a lot of information flow in both directions.
And
well, that's great, and I appreciate it. Other comments?
Yeah, just one more. Just getting started. Like, say you're an operations engineer, controls engineer, and you want to see what's available on your devices. The install is very simple, and if you want to send data out, say over OPC UA, as we mentioned earlier, you only need to ask your IT staff for like a VM and one port to be opened. Like, it's not a huge project to get started. You just need administrator rights on a VM and a port. But you can even, before you start sending to something like a client or Azure, you can even within KEPServer use the quick client just to see what data is there.
All right, good. I want our listeners to know that we're going to provide answers to the questions that haven't been answered. As I said in the beginning, we'll be sending you an email with further information. But just thanks for all the great questions. We had over 30 of them. Thanks again to our excellent speakers, Sam Elsner and Philip Bard, for sharing their time and experience. I'd also like to thank Kepware for sponsoring today's webcast. And now that we're just about done, we want to know how we did. The exit survey will pop up on your screen as soon as this webcast ends. Please take a moment to complete it as we use this information to improve our webcasts. On behalf of CFE Media and Technology, thanks for attending, and we'll see you next time.